Everyone, this is Farha nausheen of Group 316. This is my third video and the topic is Methods of Nuclear Physics. Nuclear physics encompasses a variety of methods and techniques used to study the properties and the behavior of atomic nuclei. Here are some key methods employed in nuclear physics research. Particle accelerators. Linear accelerators accelerate charged particles in a straight line. Cyclotrons use magnetic field to accelerate particles in a circular path. Synchrotrons accelerate particles to high energies using magnetic fields and radio frequency cavities. Detection techniques. Scintillation detectors use scintillating materials to convert radiation into light, which is then detected. Semiconductor detectors utilize semiconductor materials to detect charged particles and gamma rays. Next one is time projection chambers measure the trajectories of charged particles in a gas or a liquid. Nuclear reaction, fusion, combining light nuclei to form a heavier nucleus, releasing energy. Fission, splitting heavy nuclei into lighter ones, also releasing energy. Neutron capture involves the absorption of neutrons by nuclei, leading to the formation of heavier isotopes. Fourth one, spectroscopy. Gamma ray spectroscopy analyzes gamma rays emitted from nuclear transitions to study energy levels within the nuclei. Alpha and beta spectroscopy measures the energy and intensity of emitted alpha beta particles to provide insights into a decay processes. Fifth one, nuclear imaging. Positron emission tomography uses radioactive traces to visualize metabolic processes in the body. Computational methods. Monte Carlo simulations used for modeling complex nuclear processes and interactions. Density functional theory, a quantum mechanical modeling method for investigating nuclear structure. Radiometric techniques. Radiocarbon dating measures the decay of carbon 14 to estimate the age of organic materials. Isotope ratio mass spectrometry analyzes isotopic compositions for various applications. Neutron sources. Research reactors and spallation sources produce neutrons for various experimental studies, including neutron scattering techniques. Second topic is physics of enzyme substrate mechanism. The enzyme substrate mechanism is a fundamental concept in biochemistry that describes how enzymes interact with substrate to catalyze chemical reactions. The physics underlying in this mechanism involves several principles, including molecular interactions, thermodynamics, and kinematics. Enzyme structure and function. Active site, the region on the enzyme where substrate binding occurs. The active site has no specific shape and chemical environment that facilitates the conversion of substrate into products. Induced fit model. This model suggests that the binding of a substrate includes a conformational change in the enzyme, enhancing the fit between the enzyme and the substrate. Molecular interactions. Binding forces. Various non-covalent interactions contribute to substrate binding, including hydrogen bonds, interaction between polar molecules, ionic interactions, attraction between charged groups, van der Waals forces, weak attractions due to transient dipoles, hydrophobic interactions. Non-polar region of the enzyme and the substrate tend to cluster away from the water. Reaction mechanisms. Lock and key model suggests that the enzyme's active site is complementary in shape to the substrate. Covalent catalysis involves the formation of a transient covalent bond between the enzyme and the substrate, providing an alternative pathway for the reaction. Environmental factors. Temperature and pH. Enzyme activity is influenced by the temperature and pH, affecting the molecular motion and activity of enzyme substrate complexes. Concentration effects. Changes in substrate or enzyme concentrations can shift reaction rates based on the principles of chemical kinetics. Inhibition and regulation. Competitive inhibition. An inhibitor competes with the substrate for binding to the active site. Non-competitive inhibition. An inhibitor binds to an allosteric site, changing the enzyme's shape and reducing its activity.